Hi, welcome to the Olympiad Geometry Club. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Recently, I received more than 50 problems from an audience. It looks like the problem originated from an Olympiad math school in India. And some of the problems are pretty interesting. So I'll show my solution of these problems in the future as well. Okay, today we are going to talk about one problem here. It proves that in any triangle, perimeter is greater than the sum of its median. So basically, let's set MA, MB, MC are the medians of triangle ABC, right? And we want to prove that A plus B plus C larger than MA plus MB plus MC, right? So the first thing that we can think of MA, MB, MC is the formula for the MA, MB, MC, right? M equals 2, for example, MA equals 2, half of B squared plus C squared minus quarter of A squared, right? We introduced this when we talk about the Stewart's theorem. So let's just use here directly. But if you look at the inequality here, that if we just sum all of them together and directly compare to A plus B plus C, that is difficult, right? Which means we have to figure out a way to split A plus B plus C. The easiest way that we can think of is to split A plus B plus C to be A plus B divided by 2 plus B plus C divided by 2 plus C plus A divided by 2. And we can see that each one reference to one of them here. Which means if we can prove that MA is less than B plus C divided by 2, MB is less than A plus C divided by 2, and MC is less than A plus B divided by 2, then we're done. Now the question is that, can we prove this? If we want to prove this, basically it's saying MA is less than B plus C divided by 2 is equivalent to prove that half of B squared plus C squared minus quarter of A squared less than B plus C divided by 2. Oh, squared, right? It's A squared. Which means it is equivalent to prove that 1 by 2 B squared plus C squared minus quarter of A squared less than quarter of B squared plus C squared plus 2BC. Right. Which is equivalent to prove that quarter of B squared plus C squared less than actually minus this one less than quarter times 2BC, which means we need to prove that A squared is larger than B squared plus C squared minus 2BC. This is very straightforward, right? Because a squared equals 2b squared plus c squared minus 2bc cosine a. And we know that cosine a is less than 1 in a triangle, which means a squared is always larger than this one, right? Which means that ma less than b plus c by 2 is valid. And for the mb and mc, they're the same way to do the proof. Therefore, we get that ma plus mb plus mc is less than a plus b plus c. Okay? So this problem, I think, actually originates from the property that for example, ma less than b plus c by 2, right? So if you already know this, then this problem is very, very clear for you. If you don't know this, and you can think of what I did and get the same conclusion here. Okay? I hope you like this video. See you in next one. Thank you.